So welcome to our webinar. Today's topic on the Climate Ready series is extreme precipitation on the West Coast. This presentation is part of a series that's supported by Natural Resources Canada and the BC Ministry of Environment as part of the Regional Adaptation Collaborative. Our two speakers today are going to be telling us a bit about their knowledge and experience in this area. Our first speaker is Thomas White, who's the manager of the adaptation group in the Climate Action Secretariat. And Thomas is going to be talking about a project that was done to look at atmospheric rivers. Some people call them Pineapple Express events that bring large amounts of precipitation to BC in a short period of time. And Thomas's group worked with the Pacific Climate Impacts Consortium to carry out this project that looked at trends and events and ways at which we might be able to be better prepared for these types of events. When we get to the question period, Trevor Murdoch, who's the lead on regional climate impacts at Pacific Climate Impacts Consortium, will join the panel and help us to answer questions. Our second speaker is Frank Van Nijnatten, who's the Assistant Manager of Environmental Services at the City of Chilliwack. And he's going to be talking about the City of Chilliwack's experience with the significant flood event in 2009 and get into some of the details of what happened there, how the city responded, and how they're taking some steps to reduce risk in the future. So as I mentioned before, if you've got any questions during the presentation, please type them into the question box and we'll get to them at the end of the session. So at this point, we're going to I'm going to hand the controls over to Thomas, who will be our first speaker. Can you unmute him, please?
Yes, sorry.
Okay, yeah, great. All right, Thomas.
Good morning, everyone. Jim, can you hear me well?
Yes, thank you.
Okay, good. Well, thank you, Jim, for organizing this, and good morning, everyone, and thank you for your attention this morning. I'm happy to give an introductory presentation on our work with the province and our work with the Pacific Climate Impacts Consortium on understanding extreme precipitation on the West Coast. For this morning's presentation, I'd like to walk you through the general characteristics of precipitation on the West Coast, and then focus in particular on some recent work that we've done with PICS on atmospheric rivers. What you see here is the basic climatology of the province. On the left is a map showing the total annual precipitation. This is the climatology based on the period 1971 to 2000. And in a nutshell, it's telling us that the coast is wet. I don't think that's a surprise to any of us. The colors in green are showing greater amounts of annual rainfall, starting at about 850 millimeters per year. So I see the note about speaking up, Jim. I'll try to do that, but I'm having trouble with the handset, so let me know if this is okay. The panel on the right shows us the 20-year return period, one-day extreme event for the same period. And the colors in green are starting at 85 millimeters per year. Now, these are averages over very high areas, so please do note the caveat at the bottom of the text that these don't reflect the intensity experienced at specific sites, and that can be quite a bit higher than what's reflected in these maps. But again, the story is that the coast is wet and experiences heavy rainfalls. The climate change question that interests us is whether there will be changes in the degree of intensity. And there's just a correction that's 85 millimeters per in a 24-hour period for the extremes. Now, most of these extremes come in the form of atmospheric rivers. What is an atmospheric river? It's a long and narrow conveyor belt that moves moisture from the tropics to the west coast of North America. What you see here is an illustration of one. These are typically long in the thousands of kilometers and narrow. They might be 400 to 600 kilometers wide. And the moisture content in these streams is much higher than the surrounding air. And they can be detected from satellite imagery, and we'll see that in a few slides. And they can move a considerable amount of moisture. What you're seeing in the legend at the top is the amount of the depth of moisture if it's condensed out of the atmosphere onto a surface. And these things can have the amount of moisture that's equivalent to 7 to 15 times the output of the Mississippi River at its mouth. They're a very important part of the water cycle. They deliver anywhere from a quarter to half of the moisture. They're very important in California in particular, and they account for about a quarter of the moisture or the rainfall that we receive in British Columbia. And they're normal, and they're not usually problematic unless they stall. So these systems tend to move through in a 24-hour period, but occasionally they stick around longer, and that's when we tend to experience problems and massive flooding. Some examples would be the 1996 snowstorm in Vancouver in the Lower Mainland. That was a suspected atmospheric river, and then more recent flooding in Bella Coola in 2010, in Duncan Cowichan in 2009, and the example that Frank is going to talk about following my presentation. This slide shows some recent work that PICS has completed for us, updating our 2002 report on indicators of climate change to use more recent data. The panel on the left is showing you the percent change in precipitation for different parts of the province. We used a lot of Environment Canada's data and provincial data for precipitation that is compiled and housed at PICS from the period of 1900 to present. The data record is much richer in the second half of that period. And PICS looked at changes in trends for us. And what you can see is that in all parts of the province, we're seeing more precipitation in more recent times. I would note that these are percent changes rather than absolute changes. So if you cast your mind back to the climatology of the province, the absolute change is going to be greater on the coast than it is in the interior. What can we expect with more warming of the atmosphere? In general, we would expect more frequent heavy precipitation events. We would expect a shift poleward of mid-latitude storms. So these atmospheric rivers, which tend to hit California more than they do the Pacific Northwest, those storm tracks might move north, and so we might see them more frequently. We might expect an increase in the strength of the most extreme storms, and this is because with a warmer atmosphere there is more moisture available to move, and we might expect an expansion of the moist tropic zone from which atmospheric rivers draw their moisture. This animation is showing a satellite imagery of the atmospheric river that affected the coast and in particular caused flooding in Bella Coola in September of 2010. And what it's showing you as you move from the purples and blues to the yellows and reds is the amount of moisture vapor that's being transported from Hawaii in the middle of the Pacific all the way up to the coast of British Columbia. This is what Bella Coola looks like. On the map on the left, you can see that it is at the end of an inlet and essentially unprotected by and exposed to the Pacific. So there's no buffering effect of Haida Gwaii or Vancouver Island. It's almost perpendicular to the coast, so it gets the full effect of the atmospheric rivers when it hit in this particular instance. In the picture on the right, you can see the topography of our coast. All of our coast looks like this, and as you get this warm, moist air hitting this, it's going to move upslope, and you're going to get a lot of precipitation. And this is the result. So there was washout of the highway, road access to the town. The airport was flooded, and millions of dollars of damage in terms of the road infrastructure. Fortunately, I think there were no fatalities, and the community proved to be very resilient to the event. That event motivated us to develop a deeper understanding of atmospheric rivers, and with the support of Natural Resources Canada, we undertook a 2-year study that resulted in 2 reports. They're both seen on the right. The first was the Atmospheric Rivers State of Knowledge Report. This sort of summarized our current understanding of atmospheric rivers. And the second, called The Future of Atmospheric Rivers, looked a bit more in depth at options to respond. Both of these reports are available publicly on the PICS website. And the general findings from these reports were that we do have opportunities to improve forecasting and the dissemination of warnings. Environment Canada does a very good job of this currently, and there are opportunities to improve this, and in particular to communicate the significance of these events at a local level when they're expected, and which will help mobilize resources in advance of the atmospheric rivers hitting the coast. We need to have a better understanding of hydraulic impacts, and I think Frank will give us a sense of this. And in the Bella Coola instance, if I just go back one slide, if we look at what's happening with the bridges here, the real issue is the mobilization of debris in the channel that's washing out the abutments to the bridges, rather than the amount of water or the flow underneath the bridge. So there are lots of interactions when we get this amount of rainfall that we need to pay attention to. And the climate science, insofar as how much water is raining down on a particular area, only gets us so far. We need to understand the bigger system of where that water is going to go and what it's going to do. And then I think adaptation for this particular hazard isn't that much different than for other hazards. We should be looking at opportunities to limit development in and move out of hazardous areas, assess critical infrastructure and upgrade it where necessary. And the following presentation is going to go into depth on that, and then support community preparedness and resilience. The next few slides I'm just going to show you are a sequence of satellite images showing an atmospheric river for the dates that Frank is going to be talking about. So this is just confirming that there was an atmospheric river present on those dates. As you look along the spectrum towards the bottom, the yellows, reds, and purples are showing the amount of water vapor in the atmosphere. This particular one is not an exceptionally strong atmospheric river, but it still caused a lot of trouble. And I think it's not just, as we'll see, not just the amount of water, but the fact that a lot of warm air is present in an atmospheric river, and that can cause snow and whatnot to melt. I'd like to close just with this picture of the city of Sacramento in 1862. It was inundated by a flood, and in retrospect, an atmospheric river, or actually a sequence of them, is suspected. I just put this up there to emphasize that these are not new phenomenons. Extreme precipitation is common on the coast. It's an important part of the water cycle. But with climate change, we need to understand how this might change, and in particular, whether extremes will get more extreme or more common. I'd like to thank you for your attention. I'll turn it over to Jim, and I'd be happy to take questions after Frank's presentation.
Unmuted.
Okay, great. Thanks very much, Thomas. Appreciate that. So again, if this triggered thoughts for you or questions, please either type them down or note them down to ask later. We'll just switch things over so that Frank can give his presentation. so just be patient with us for a moment. And apologies if there's some background noise here because of some construction. Hopefully that doesn't interfere too much. Okay, great. So Frank, your presentation looks like is up, so go ahead, please.
Good morning, everyone. My name is, as was said, Frank
Muted.
and I work at the engineering department at the City of Chilliwack. And I am pleased to have the opportunity to present the Chilliwack experience with the 2009 flood event and the results of the Greendale Drainage Study. The Greendale Drainage Study was completed by the engineering firm Urban Systems Limited. In the first week of January 2009, the city experienced an unprecedented flood. This photo illustrates conditions in central Greendale. It's on South Sumas Road, just west of Sumas Prairie Road, with any of you are familiar with Greendale. This air photo taken on January 9th illustrates the west end of Keith Wilson Road. As you can see, several of the roads in the area were underwater. In addition to the Greendale, there were also other neighborhoods in Chilliwack that experienced flooding, and this air photo shows the flooded area on the east side of Chilliwack. Temperature and rainfall data are important tools in analyzing this flood experience. This graph shows the daily high temperatures, the red bars, for the period January 1st through to the 9th. And you can notice the dramatic warming trend starting at about January the 5th. In addition, the blue bars on the top show the rainfall each day, and the significant portion is there are 50 millimeters recorded on the 6th and 75 millimeters reported on the 7th. The city has two stormwater pumping stations in Greendale, the McGillivray and the Collinson stations, and they both operated normally up to January the 6th. From January 6th to the 14th, they operated continuously with all pumps running. And these air photos, if you can see, they can show the water running through the dikes from the Greendale area into the Vetter Canal. Also, the Henderson flood box is used to control and direct flow out to the Fraser River. The two pictures on this screen illustrate the normal water condition on the left and the January 2009 flood condition on the right. And as you can see, the right photo illustrates that the control valve and operating mechanism are actually overtopped by the extreme high flows. The weather in January 2009 included extended period of sub-zero weather, followed by snow accumulation, followed by rapid thaw and heavy rain, which all contributed to creating the flooding event. The statistical significance of the flood has been calculated to assist the city and the community in understanding the performance of our drainage system. The frozen ground, snowpack, rapid warming, and heavy rain together produced a flood with a reoccurrence frequency considered to be 1 in 200 year. The ditches and culverts in Greendale have a capacity to handle the flows from a 1 in 10 year rainstorm event, and the existing pump stations are sized a bit more conservatively to handle the flows from a 1 in 25 year storm event. By way of comparison, stormwater pipes systems installed in new developments are currently sized to handle the 1 in 10 year rainfall event, and the 1 in 100 year events are designed using overland flow paths. During the January 2009 flood, state of emergency was declared in Chilliwack, which triggered the provincial emergency program, allowing the processing of damage claims. The province reported approximately 195 private property claims with a total value of 1.6 million and 32 public property claims from the city totaling approximately $4.3 million. And this map illustrates the distribution throughout our community of the 195 private property claims received by Provincial Emergency Program. And you can also see that that all the neighborhoods were affected, with the largest number of claims coming from the Greendale area. And this map illustrates the public city claims, and all claims were road-related, involving damage to ditches, culverts, embankments, retaining walls, and underground utilities. Over 90% of the hillside road failures occurred in rural rather than urban areas. The city of Chilliwack is made up of 3 drainage areas. The Greendale neighborhood is known as our western drainage area. Areas to the east of Lickman Road boundary drain north to the Fraser River through the Chilliwack drainage river system. To assist the engineering consultants, a detailed topographic map was created using LiDAR aerial mapping system. Greendale drains from east to west and is unique for having the extremely flat western portion. And this is noted on the map by the widening of the elevation color bands. A computer model of the drainage system was created. The January 9th air photograph was utilized to calibrate the output of the model. Here we see the air photo compared to the computer-generated image for the drainage model. The model was adjusted, calibrated to match the experienced flooding. And the calibration technique was utilized throughout the Greendale drainage area. The model was then used to prepare system performance and flood profile information for each of the milestone rainstorm events. This slide illustrates the 1 in 10 year rainfall event. This shows the 1 in 25 year rain, the 1 in 100 year rain, and finally the 1 in 200 year rainstorm as experienced in January 2009. The red dots on this diagram show the buildings reported as being flooded. So you can see there's actually quite a few of them. So the report summary. The focus of the report was to answer four key questions asked by our City Council. And the first question, what caused the flood? The report determined that the flood was caused by a combination of climatic factors, extended period of sub-zero weather which froze the ground, and accumulation of snow followed by rapid thaw and heavy rain. Second question, how significant was the rainstorm? The study estimates the statistical significance of the flood as equivalent to a 1 in 200 year event. And of course, this is much worse than what the Greendale drainage system was capable of handling. The third question, what parts of the drainage system failed? The report found the following parts failed. The ditches and culverts sized for 1 in 10 year events were inundated and overwhelmed by the flows produced by a 1 in 200 year event. Also, the flood boxes and pump stations, similarly designed for much smaller storm events, were unable to convey the stormwater flows. Our consultant then went on to produce a list of suggested upgrades for the drainage system. If improved system performance is desired, the first suggestion is pump upgrades to elevate the capacity from the current 1 in 25 year to 1 in 100 year capacity. The work would include upgraded pumps, motors, electrical controls, and service and dedicated generators. And the cost for those pump station upgrades for the 2 pump stations was a total of $5 million. The second suggested upgrade involves replacing select system culverts to improve the flow to get the water to those pump stations. And this would involve 71 culverts, estimated replacement at about $2.2 million. The third suggestion was upgrading, is the construction of 2 new cutoff channels on the McGilvery system and the second on the Lewis Slough system, and this upgrade had an estimated cost of about $2.6 million. And the dashed red lines on this map basically show where those cutoff channels are situated in the Greendale drainage area. The fourth suggested upgrade involves the identification of the most flood vulnerable homes, then working with owners to identify on-site solutions. And the fifth suggested upgrade involves installation of water level gauges at specific locations on critical primary channels, and then the data from these gauges would be used to improve the understanding of the drainage system. And that upgrade had an estimated cost of $130,000. Financial implications. The suggested upgrades are currently not all funded in the city's budget or in our 10-year capital plan, although we will continue to make inquiries regarding grants from senior levels of government and will include identified upgrades in future budget deliberations. In addition, residents also have the option to consider funding some system upgrades through local improvement process, and this could bring funding from for identified upgrades sooner. And of course, the local improvement process allows upgrades to proceed with the cost borne by the benefiting properties. And there are approximately 1,000 private property parcels in Greendale. The suggested improvements at a total of $10 million, which would be roughly $10,000 per property. The improvement projects currently underway. The Collinson Pump Station construction actually just began last week, and it's a $2.5 million project. It has funding from the flood protection program at one-third by the province and the federal government, and it will increase the pump output from approximately 2.5 cubic meters a second to approximately 5 cubic meters a second, so basically doubles the capacity. And the new station will also include a standby generator, which it currently doesn't have, and also automated intake screen cleaners, just to keep the debris away and making sure that we don't get pump cavitation. And also the annual budget for culvert upgrades in our annual capital plan has been increased from $100,000 to $600,000. So that's going to go a long ways in replacing some of those undersized culverts sooner. And also the entire document, if anybody's interested, is available on the City of Chilliwack website to look at it in more detail. And that concludes my presentation.
Unmuted.
Okay, great. Thanks very much, Frank. Appreciate that, getting into the details of what's happened in Chilliwack. At this point in time, we'll move into the questions for those that have questions. As mentioned before, if you've got a question, please type it into the chat box, and one of us will read it out. Just hold on a second here. Okay, so we have one question to start with here. The first question is there an understanding of how long an atmospheric river could stall for? So I don't know if Thomas or Trevor, if one of you might want to address that question. And we'll just make sure we've unmuted you here before you to do that. Who wants to take that question?
Well, I can start, and then perhaps Trevor has something to add. I would say 24 to 36 hours, not much longer than that. Sometimes there are two in succession, and so the problems there are that the soil is immediately saturated, and there's nowhere, when the second one hits, there's nowhere for the excess water to go. One of the planning exercises that has been done in California is to have a fictional sort of superstorm and model what happens with that, and to they designed that scenario as two atmospheric rivers in the two biggest atmospheric rivers that have ever been observed happening in succession, so within 1 week of each other, and what kind of flooding does that produce. So they don't stall for a very long period of time. I would say more than 48 hours, but 24 to 36 hours is quite a lot of rain. Trevor,
I don't have anything. The only thing that I would have to add is there's some sort of reason to be concerned that with climate change, atmospheric rivers may stall for longer. The work to actually sort of analytically analyze that question is just underway. So we don't have a really good definitive answer to that right now, other than, as I say, sort of some reason to suspect that may happen.
Okay. Our next question is for Frank. For the Chilliwack upgrades, are federal or provincial environmental approvals needed, or does the emergency trump? For example, DFO had approvals.
No, there were approvals required. So we did a Section 9 environmental application. We also did the Dike Maintenance Act application, and because there is very little work actually in a water course, the issues weren't significant.
Okay. Next question sounds like it's probably for Thomas and Trevor. Is there any statistical evidence of an increase in the frequency in atmospheric river events?
I think I'll let Trevor answer that. I don't think that from my perspective, from the historical record, that's very difficult to tell. In particular, because atmospheric rivers have only they're observed using satellite imagery, so you really only have confirmation that atmospheric rivers were present for the period for which the satellite imagery is available. But PICS has done work, and this is featured in the two reports that I pointed out, looking at what is happening in climate models, and I think I'll turn it over to Trevor to talk about that.
Yeah, that's exactly right. The records are just too short to really answer that historically. But yeah, the future projections that we've done, and this again is a little bit preliminary, but because we've only looked at I think it's from 4 different global climate models. By the 2050s, so the middle of this century compared to the past, we're looking at roughly a doubling of the number of days under which most of BC would be exposed to atmospheric river events, and so that includes in the interior. So the coast currently has the largest number of events, and is much more affected than the interior. There's like a few days per year in the interior, and that's projected to double both on the coast and the interior.
And Trevor, would that information be in the reports that that Thomas mentioned as well?
Yep.
Okay. So there is a link to one of the reports, at least in the chat box, and we'll make sure that we have links to those circulated as well after the webinar for anyone who's interested. I guess as a question for anyone, has anyone tried to map out extreme rainfall events or localized flooding in the Lower Mainland?
I guess I can respond a little bit. The city of Chilliwack, of course, we have the floodplain mapped out, which is kind of different than this localized type of flooding that we experience from rainfalls or infrastructure that's undersized. We don't really have it mapped out per se, but between our engineering department and our operations department, we typically know which areas within the city are more vulnerable, or which ones may be more likely to have some minor flooding in the event of heavy rainfalls. And obviously our Public Works Department monitors them a little bit more closely, particularly if they know heavy rainfalls are coming. As an example, if they know high rains are coming, they'll make sure that all of the catch basin grates are clean, just to assist in getting the water into them sooner. And the same thing with some of the culvert inlets. They'll go make sure that there isn't any debris, so that the system that is in place can operate as good as it can.
Okay. It looks like the next question is for you as well, Frank, or the next couple perhaps. So the question is, will there be any consideration given to zoning changes at Chilliwack, or is there confidence that flood control measures will be enough to ensure that private homes can remain in these locations?
We are currently in the process of updating our floodplain bylaw, and that floodplain bylaw, which is more closely linked to the diking system and the flood construction level based on a flooding event from the Fraser or Vedder rivers. But the elevation in the Greendale area is susceptible to them as well. It just happened to be that this 2009 event wasn't caused by that. It was just caused by the inability. In answer to the question, we will look at vulnerable areas and those that might experience flooding, and we will consider for future whether we're going to change the bylaw and require or not allow certain developments to occur in certain areas. Or, for example, we may require a higher level of flood proofing to minimize the damage in the event that there was a flood. But of course, it's always this trade-off between not allowing development and allowing your community to grow. So it's going to be an ongoing process.
And I guess a related question, has Chilliwack considered upgrading design guidelines for pipe size on greenfield or new build development? I'm assuming this means things like culverts.
Right now, we haven't gone beyond the 1 in 100 year rainfall event. So as it occurs right now, a new development would be required to design their subdivision or the development for the pipe sizing to accommodate the 1 in 10 year, but they would also have to make sure that whatever their road design or their curb and gutter and sidewalk, that the 1 in 100 year rainfall event could be accommodated by overland flow. In other words, it would have to flow down the streets into water courses. And again, this design requirement would mean that there would be no flooding for a 1 in 100 year event with the combination of the overland and the pipe flow.
Okay, I'm going to ask my colleague Steve Litke, who just happens to be sitting with us here, to answer the next question, which is using the City of Chilliwack experience as an example of a possible event. Are there examples or opportunities for multiple local governments and or local First Nations governments to collaborate on these types of assessments? Any examples of joint planning or joint implementation of mitigations?
Yeah, thanks, Jim. We are facilitating a collaborative planning process throughout the Lower Mainland, looking at developing a regional flood management strategy, and a number of folks on the webinar today are part of that. And really, as a first phase, we're looking at improving our information with respect to different flood scenarios, the degree of vulnerability to a large flood in the Lower Mainland, and also reviewing the current status of flood protection works and land use policies. So I guess that's a long way of saying yes. That's one example, and we do hope that there can be some lessons learned that can be applied to other regions throughout BC. And I guess I should say that we're not focusing in this Lower Mainland initiative. We're not focusing on localized extreme rainfall. We're really mostly concerned with a large Fraser River freshet flood, as well as a large coastal flood with respect to sea level rise and storm surge.
Great, thanks very much, Steve. Just a comment here that someone wanted to mention from Harshan from APEG BC. He wanted to quickly highlight the fact that that APEG BC, the Association of Professional Engineers and Geoscientists, is doing a professional practice guidelines on incorporating climate resilience in the design of public infrastructure in British Columbia. So I'm sure there'll be more on that in the future, but that's a project that's just getting underway. A question, getting back to questions, is can someone discuss the distinction between atmospheric rivers and potential forecasting more granular weather bombs? I guess that meaning other events that bring high levels of precipitation to the coast.
So I can say a little bit about that. So we're just starting now with the most recent climate model results associated with the most recent IPCC assessments. So these are CMIP 5. Sorry to use the jargon, but these are the most recent climate models, and with that, we've downscaled those to high resolution, and we're for the first time able to start looking at extreme precipitation events. And you'll see in the reports that you've linked to that we have precipitation totals, and just in terms of annual total precipitation. Then we also have the 1 in 20 year return period. So that's the 1 in 20 year expected event. And then there's also, we're able to separate out atmospheric rivers and count atmospheric river days separately. That's as far as we've been able to take it so far. So the 1 in 20 year event doesn't really distinguish between whether it's an atmospheric river or whether you have just a local convective event, because you have just because of having larger precipitation. So we're kind of just in the beginning phases of getting at extreme precipitation. Another thing that a lot of people are interested in is IDF curves, these intensity, duration, frequency curves. And again, even there, we're in the early stages. Probably in the next 1 to 3 years, we may be able to start looking at projected changes of IDF curves. But again, you won't really be able to separate between convective events versus these advective events that are coming off the sort of fire hose of the Pacific. So I don't think I'm really answering the question, other to say we're just getting close to starting to work on answering that question.
Okay, that's great. Thanks, Trevor. Another question from a participant: does a state of emergency have to be declared to allow people to claim for damages? I guess this would be under the provincial and federal programs. Frank, do you know the answer to that?
I don't. I think that is the case. I think that there has to be a state of emergency declared before people can make those claims. I'm pretty sure that the provincial emergency program doesn't accept, but don't quote me on that. I'm not positive. Okay.
Yeah, I think you're right. I think that a local state of emergency does need to be declared for that to kick in. For developing policy for various land uses, what would be the best use for the likelihood of a flood happening? For example, 1 in 200 years, 1 in 100 years.
Sorry, say that again.
Well, the question is, I guess what the person is trying to get at here is and I think you provided this some in your presentation as well, but if you could just reiterate it as to what frequency should be used in land use policy. Is it a 1 in 200 year, 1 in 100 year?
Yeah, our land development bylaw has a series of requirements for determining what the flows are going to be, and they have a variety of rainfall events that they have to use in sizing the infrastructure, both the piping and the overland flow. So they have to size for not just the long duration, but the very short duration, high intense rainfall. So they have to make sure that it can handle those 15-minute peak periods as well as the longer 1 in 100-year events, to pipe the 10-year and to accommodate the 100-year via overland. In addition to that, the diking system for the Fraser River is designed for the flood of record, which is basically a 1 in 500-year event.
Okay. Well,
Not sure if that totally answers the question or not. There's a lot of factors in play, and the subdivision development bylaw, and I think that most municipalities are similar to Chilliwack's, and it depends on the size of the development. So if it's a 1 or a 2 lot subdivision, they typically don't have to do as exhaustive of a process. If it's more than a certain size, a few hectares, I believe they actually have to show the modeling to confirm that they've used the correct rainfall events for the drainage areas.
okay. Thanks very much.
I can add just a little bit to what's awkward about that is that you'll notice the future projections in the reports we've been talking about and that I've mentioned are 1 in 20-year events, and what's needed for planning are these much longer return periods. And because of the length of the time series that we have available for us for the climate model projections, it's difficult to go much beyond 1 in 20 year. We can maybe go 1 in 50, but then you're really sort of pushing the limits and increasing the uncertainty. But we do have good sort of theoretical and statistical reason to believe that the longer return period events would be expected to increase by at least as much in a relative sense as the shorter duration. So we'd look at the 1 in 20 year rather than planning and saying, oh, we don't know what the 1 in 100 year event is and what the 1 in 200 year event is. We'll just use the past. You'd want to at least consider the relative change in the 1 in 20 year and possibly more. And it's hard when you're used to making these very quantitative decisions to have to take some number that and just go with at least that. But that's where we're at currently.
Okay, thanks, Trevor. Next question is there a seasonal aspect to the frequency of the atmospheric river?
They're much more prominent in fall and spring, so it's the season that's already wet for us, November through April, roughly.
Okay. Next question might have to be a combination of various folks contributing here is how do you monitor or estimate for the combination of extreme factors, as in Chilliwack's case, frozen ground, snow, and rain probabilities all happening at once? What is appropriate? Let's add high tides and storm surges as well.
Well, we're fortunate in Chilliwack that we're not affected by high tide, but we are cognizant of weather pattern changes, and I'm certain that that's going to be affected in the future flood profile of the Fraser and Vedder rivers, obviously. But also, as we move forward, we will have to look at and upgrade our IDF curves, the intensity, duration, frequency of the rain events, and that's going to have to be incorporated into our development policy to make sure that the conveyance system can in fact handle the flows with no flooding.
And it's Thomas here. I think this is this came up in an indirect way through the process, the two studies that we produced in terms of how weather forecasters can not so much improve the forecast, but provide more information with those forecasts that is targeted at people who might be impacted by these events to help them understand what to do. So this doesn't get so much at the monitoring, but I think what we saw in Frank's example in Chilliwack is it's not just the amount of rainfall that's happening, it's also the warm air and the fact that there was a lot of snow on the ground. So I think Environment Canada can do a really good job of forecasting extreme precipitation events and things like atmospheric rivers and giving advanced warning. But I think where we can go a little bit further, I think, in the next couple of years, is to understand how seasons have developed and know that these kinds of impacts are possible. So again, with atmospheric rivers comes warm air and heavy rainfall, and then thinking about examples like we've just seen in Chilliwack. If we're in that kind of situation again, we can prepare in advance. So I think it's more about not so much the monitoring, but the packaging of information about how these impacts occurred, and it's almost always multiple circumstances. It's not simple, but if we can target the dissemination of the weather warnings based on seasonal information, then we can, on the weather forecasting side, start to warn people in advance that they should be looking out for these kinds of impacts when we know that something's coming. And the forecasting it always gets more reliable closer to the event, but you can kind of get an indication that an atmospheric river is developing more than 48 hours in advance. So I think that's the opportunity it won't prevent the thing from happening, and it won't prevent the damage from happening, but you can mobilize resources and get prepared and get crews out, as Frank was describing, I think, in answer to one of the questions. So there are things you can do in advance if you can if you have a better understanding of what the impact pathway is.
Yeah, it's Frank again. And that's a good point. One of the things that we can do is, particularly if we have some advance notice, and we typically do, of a weather front coming in, we also have the opportunity of manually pumping down the system perhaps to a lower elevation than we normally do. Currently, the pump stations operate at set points, and they're all automated, and the pumps start and stop by themselves based on a certain level in the pump bay and the pond bay. But if we know that there's going to be a significant rainfall event, then we have an option of going to that station manually, pumping down to perhaps a lower elevation, and thereby creating a little bit more storage and lessening the risk of the flooding. And that perhaps could be an interim measure until the pump stations are all upgraded to provide that 1 in 100 year rainfall event. But the same thing could happen if we have it designed to a 1 in 100 and we're expecting a 1 in 200 year event, or we know that the ground is frozen and we have a bunch of snow and we know that we're getting Pineapple Express. We have the same option. We can go there and we can manually run those pumps to lessen the risk.
Okay, this next question is for you as well, Frank. Does the city of Chilliwack treat farmland differently? For example, do you use ARDSA, the agricultural guidelines for flood protection?
We did we still do. When ARDSA came in the 80s, it designed the system to a different requirement. But of course, agriculture was much different in the 80s than it is now. Back then, the majority of the farms were dairy or cash crops. So it was hay or cornfields, and those types of crops could easily handle being underwater for perhaps up to a week at a time in the winter months, and it wouldn't hurt them. Today, a lot of that has been turned into, say, blueberry or nursery crops, and a lot of those type of agriculture can't stand to be underwater for several days. So So we really have to look at some of those areas where agriculture is changing to see if there are things we can do to upsize infrastructure, that being water courses and culverts, to try and reduce the amount of time that agricultural land will be underwater during those significant events. Because currently, when ARDSA was done, it allowed some of those agricultural fields to be underwater for up to 3 days, and then it'll drain out in time and not really cause any damage. But again, that's just for the land, not for the buildings.
Okay, we have time for a couple more questions here before we wrap up. The first one is, what rationale for planning for compounded probabilities versus traditional singular event probabilities? Is there acceptance among professionals and politicians to plan for compounded probabilities? Is this overreacting or good infrastructure planning?
It's Frank. Yeah, I'm not sure. I think that municipalities should consider that, because this has happened. It certainly can happen again. It's certainly not unheard of to have frozen ground and snowpack followed by heavy rainfalls. It doesn't happen often, but it certainly does happen. So there should be an allowance for these types of events, and it should be included in the requirement for developments or for long-term planning of infrastructure.
Any of the other panelists want to add to that? Otherwise, we'll move to the last question.
I would just agree with Frank. I think what we learned over the course of our project, and I failed to mention in my presentation, the Ministry of Transportation also had a companion project where they looked quite specifically at the provincial transportation network and what atmospheric rivers meant for that. The pictures of all the bridges and the highways in Bella Coola I showed you are from that work. And what they found is partly compound probabilities and partly from an engineering perspective, you need to understand what else is going to happen. So it's not strictly speaking the amount of rain that falls, but what that rainfall does on the ground. You need to understand the hydraulics, what's going to happen in stream channels. What they found in the case of bridges is the bridge deck. There was still room for water to go underneath the deck, but it's the length of the span and the abutments that were affected most, and which would tend to suggest, if you're replacing a bridge, to build a wider bridge. But so I think understanding the probabilities of how much rain might fall in a particular spot is only part of the challenge, and there's a lot of engineering type studies of the sort that Frank told us about that also has to happen to understand what this amount of rain or this amount of snow actually means on the ground.
Yeah, I should also add in Chilliwack, in addition to the infrastructure, our Public Works Department has an annual ditch cleaning program, and in 2014 they actually cleaned 40 kilometers of ditches in the Greendale area, and that was in an effort to help convey the flow to the pump stations. Certainly in the rural areas, the vegetation has a very detrimental effect on the conveyance capacity of those water courses. So certainly having a program to maintain those goes a long ways in keeping the water moving.
Okay, we have time for one last question before we wrap things up, which is, has there been any dialogue with private sector insurance providers, including incentives for improved flood control, changes in zoning, etc., related to flood planning?
Yeah, I can speak a little bit to that. There hasn't been any formal dialogue. I do know, however, that the insurance sector is very concerned about this, and that in the last few years, claims from water-related damage exceeded claims from fire-related damage. So these kinds of events are very much on their radar. They don't, as I'm sure many people know, you can't get private insurance for residential for residences for overland flooding, but where it's related to sewer backup, you can get insurance, and so they're very concerned about the state of local government stormwater systems. They're promoting things like the use of backwater valves, etc. So it's as an industry, extreme precipitation is very much on their radar screen. They've sponsored work through the Institute for Catastrophic Loss Reduction and also at Western University to look at IDF curves. So that there are conversations happening. They have an interest. They are definite partners in understanding what's going to happen.
Great, thanks very much, Thomas. Well, I'd just like to take this time to thank our speakers, Thomas White and Frank Van Naten, as well as Trevor Murdoch, who's helped us with the panel discussion here. And thank you to all the attendees for your great questions and for actively participating in this. I found I learned something as well. As mentioned before, the presentations and the recording will be available on our website at retooling.ca in the next week. And I'd also like to thank Natural Resources Canada and the province of BC for supporting this work. We're always interested in future topics like this, and so you can expect there'll be some upcoming webinars on other community case studies and issues related to coastal climate change and flood risk and adaptation in the next couple of months, so stay tuned for that. As you exit the webinar, there is a survey, so please take the time to fill out the 5 or 6 questions and provide us some feedback. We're always looking for ways to improve things and again, for future topics that you are interested in. So again, thanks very much, and have a good day, everyone.